Hi, my name is Tiana Human. I'm from Microsoft. Prior to coming to Microsoft, I spent almost 20 years of my life as a clinician, technologist, and researcher in healthcare. And in my journeys and travels from researcher to working at Columbia University in cardiothoracic surgery for about 15 years, and then also being their director of clinical informatics. I landed at Microsoft as it afforded me an opportunity to really pursue the innovative ideas that I was interested in. And so I've been here for about 4 years. I have to say I miss clinical medicine every day. There's a special thing about touching another human being and having that trust, and I really appreciate that and honor that. But I have to say in my last 4 years here, I've also been absolutely blessed to have the support of exploring new ideas. I've been working with Paul and Ryan, the co-founders of the Clinical Research Innovation Hub, for the last year and a half, and specifically on accelerating clinical research trials with industry standards organizations such as CDISC. My focus as an architect in technology strategy in the office of the CTO of Microsoft has been in environmental sustainability and health and life sciences, and really with a specific eye on data sharing, data security, data analytics, and transparency. And so today, what we're going to do is take a tour of some of Microsoft's key, let me fix something on my desktop here, key innovations for organizations to share and generate insights across diverse protected data sets. Some of these capabilities are in production and available to the public either through our Azure Marketplace and GitHub. Just a reminder, when I was coming up in research, I always used a LAMP stack, Linux, Apache, SQL, and PHP, open source, because I could not afford Microsoft technology. And what has happened over the last, 7 years or so is that Microsoft has had an acceleration of embracing open source. And in some instances in our industries, we have over 80% of what we do is open source. And so that's really also been music to my ears as a researcher. So, with some of the technologies we'll talk about today, we talk about are in private or public preview. And this means that we're currently collaborating with customers or academic institutions on testing and fine-tuning these capabilities. It's important for our public and private preview capabilities presented today that we ask you to acknowledge that what you see today may not be what is put into production in the future as we refine these.
Hey, Tiana, your slides are not advancing if you've been advancing.
Yeah, I am advancing it now.
Okay.
So, first, we're going to talk a little bit about Azure Data Share. It's a simple and secure service for sharing big data. Just to level set with everyone, sometimes we talk about Azure every day, but that's just us at Microsoft. And so when we talk about Azure, what we're talking about is the Microsoft Cloud and having all of these capabilities on the Microsoft Cloud. And the Microsoft Cloud is called Azure. So when we think about data sharing, we think about cross-organization, big data collaborations. And these collaborations, especially when we're looking at the types of data sets that Superfund is looking at, it's not just a single data set or a single data and industry vertical. We need to look at across multiple different verticals that may not be readily apparent in order to really solve these complex problems around climate change and the effect of the environment on the human state. And so in a world where data volume, variety, and the types are all exponentially growing, organizations really need to collaborate using large data sets. In many cases, this data is most powerful when it can be shared and combined with data that resides outside our organizational boundaries. Again, looking at at all these data sets and industry verticals listed here on this slide. Microsoft is investing in data sharing because customers all over the industry, all over the world, are looking to share data with their partners and their customers. We have customers approaching us from retail, automotive, utilities, farming, finance, healthcare, research, education, and government sectors. A typical scenario is to share data with multiple entities so that their ecosystem can combine this data with their own data or other data from third party to run analytics to derive insights, because that's really what data represents to us. So how data is shared today? For customers sharing data in a simple and governed way, this is challenging. Common data sharing approaches uses FTP or web application programming interfaces. They're complex and require infrastructure to manage and knowledge of code. We don't always have those folks around to help us. These tools do not provide the security or governance required to meet the standards that are imposed upon us around privacy and just our enterprise in general. And they're not suitable for sharing of large data sets. I don't know if anyone has ever tried to move a large data set and you go home, you leave at nighttime and you queue it up and you hope maybe it's ready in the morning. I can remember doing that. To enable enterprise collaboration, we created the Azure Data Share. And it's a new data management service for sharing big data across external organizations in the Azure cloud environment. Majority of our customers are looking to share time series data, which gets updated on a regular basis. If you look at how data is shared today through FTP and APIs, this is not doable. And so they require a lot of maintenance, and all these technologies just do not work for sharing these large amount of data. So Azure Data Share it makes data easy to share, it's flexible, it's secure and controlled, and it has enhanced analytics. These are the core tenets of our data share. So how are customers using data share? So cross-organizational big data analytics is a key component of this. In all industries, we see the need for data sharing between partners. And analytics outsourcing is another scenario we have heard about from different customers as well as academic centers. Some of our customers don't have the expertise or other data sets required to analyze the data to derive insights, and so they outsource it to someone else, or they try and work with organizations to combine their data. Moving data from one data owner to another data owner, and then maybe through a service provider, is inefficient and incurs all kinds of security concerns. What I'd like to show you next is, oops, let me go here, is how our data share works. So the data share works from a source store to a target store. So if you think about, we were talking about the Azure cloud. So this is someone who is in the Azure cloud and they have a data store, that would be the source store. And then they want to send an invitation to someone to actually access their data and share their data. And that data will move either as a data snapshot, or it can be accessed in place at the origination of that data store. And so you receive an invitation, and the data either moves to your data store, or you have access to the data where it resides. What I'd like to do right now is show you a video of a video demonstration of the interface that allows for data scientists to share the data. It's about a 2-minute video, and let's see how this goes.
In this demo, John from Consortium wants to share product data with data scientists at other organizations. Product data is stored in John's Azure storage account and updated daily. John logs into Azure portal and opens Azure Data Share. He creates an Azure Data Share account. Once it is ready, he goes into the new resource. John creates a new share by giving it a name, description, and terms of use. He chooses the product data stored in his Azure storage account. Enters recipients' email addresses. And schedules a daily refresh so that updates can be sent to recipients automatically. John reviews all the information entered and creates the share. He verifies that the share has been created successfully. Jennifer is the data scientist at Fabricon who will work on the data. She received an invitation email and follows the link to open Azure portal. She views details of the invitation, agrees to the terms of use, and specify a data share account to accept the invitation into. Next, she specifies the storage account and container where data will be written into, and enables daily refresh. After the daily sync, Jennifer verifies data is in her storage account. She can now process the data using any Azure Analytics tools.
Okay, so let's go back to our presentation. And I would ask if everyone can see my desktop again.
Yes, you're good, Tiana.
Okay, all right.
It shows expand analytics.
Perfect, perfect. So one of the core use cases that we ended up there on that demo for is expanding analytics. And so what Azure Data Share lets us do is to collaborate on these large data sets. We combine existing data with shared data to enrich analytics use cases for deeper insights. These enhance insights in the modern data warehouse. Also, our Azure storage integrates with Azure Analytics services for preparing, processing, and analyzing data. In many cases, data is at its most powerful when it can be shared and combined with data that resides outside the organizational boundaries between different entities and third parties. And Azure Data Share really enables us to do this enterprise cross-organizational data sharing across these organizational boundaries, and is something we're very, very excited about. I had the opportunity to work on this 4 years ago when I first came to Microsoft, and it was just an idea, and it is exciting to see this in practice and available to the public now. So cross-organizational, one of the use cases that we see around this is cross-organizational big data analytics. And in this scenario, we have data providers that share data with research partners. We have data consumer that combines data received from multiple research partners with their own data to drive insights. And so why we're doing this through the Azure Data Share is, as you can see, it's easy to use. There's no infrastructure to set up. everything is already on the cloud. And then managing sharing with multiple partners is from that single dashboard that you saw on the demo. And importantly, many times we'll receive a data set, but data sets are not static, especially when we think about clinical data or patient data, or really any kind of data that we're going to be doing analysis on. It's dynamic and it needs to scale. And so what Azure Data Share lets you do is it allows you to do regular updates on this data as you can create more and more depth and analysis into the data. Another, I think I went the wrong way, sorry. So some industry specific use cases are around data consortiums. Data consortiums are incredibly powerful, and we are going to talk about how data consortiums can come together in a secure, structured way in our next discussion, which is around Azure Always Protected. So the Azure Data Share is in public preview with Microsoft. That means that the public can work with Microsoft to deploy Azure Data Share, and we receive feedback from those using it to help us refine it as we put it into final production, which we call then generally available. And so Azure Always Protected is also part of the work that we did 4 years ago. And that was really, how do we create these consortiums? And this, what I'm going to show you is what we call private preview. And so this is something not publicly available, but select customers that have a deep investment in accelerating this work will work with us, can be selected to work with us to help us further develop this from where it is now. So the foundation of a sustainable multi-party ecosystem and the associated data collaborative is based on how we design and align on fundamental principles of the trust framework that manages platform functionality, it manages the policy, contractual agreements, and while providing the necessary safeguards and protection for data and members of the ecosystem. And so this is the consortium around designing ecosystems. So we call consortiums ecosystems, we call them collaboratives. You'll see multiple different names here as we have grown over the last 4 years trying to find just the right name. But the purpose of these consortiums are to allow for individual parties that have highly sensitive data to come together and share that data within a trusted framework. And that trusted framework is really the constitution that everyone in the consortium agrees to around how that data is used, who can use it, and how we protect it as a consortium. As part of our core work on Azure Always Protected capabilities, we identified some large-scale needs and blockers to trust in cloud services. 3 of the common needs that our customers have told us about over the years is that they need customer-controlled encryption. They don't, although Microsoft security is the best out there, they want to have control over their security and over their data. And so customer controlled encryption is a key component of Azure Always Protected. The owner of the data has full control over the access and security of the data. They provide and manage and approve master keys, so encryption keys, data encryption keys, the encryption algorithms, and also key rotation policies to ensure security. The second one is enablement of fine-grained access policies. So these include access to data being checked for compliance with enterprise level policies. So your institution has security policies, and these align with them. And then also tamper evident audit logs. So when we think about a consortium and we think about data sharing, and this is an ecosystem, it's important that there is transparency and security around the security and the audits and the keys that people are using to access this data. If we have this in a centralized location, there is always the potential that whoever has root access to that computer that's holding that data could go in and change the data. And we know that this is a large problem in clinical research. Data fraud is real, very real. And so what we have is tamper resistant or tamper evident logs that are placed across all the consortium's infrastructures. And it is a mirror, everyone has a mirror copy of this distributed ledger. You may have heard that term in blockchain. And blockchain is a data layer. It's a shared data layer. And so we use part of that technology in Azure Always Protected. Every person or entity that accesses that data is that data transfer, that data access, that data sharing is all logged, think of an accounting log, on this shared ledger. This ledger is immutable. It means you can't, once something is logged there, you cannot change it. Again, just like an accounting ledger, where if you put in a line, a transaction, you can't go back and erase something. You have to, if you made a mistake, you have to go back and put another transaction to account for that mistake. And so we use this in the Azure Always Protected, and it's a key part of our security. So enabling trust with Azure Always Protected. While there may be general agreement across all the systems within our systems that they're very interdependent, the reality is that most of our systems are still operated in relative isolation. And this, again, is a really big problem in research because we need access to multiple different systems, even within our own organization. Diverse stakeholders realize trustworthy and secure data sharing and collaboration are required to address operational challenges and realize strategic competitive advantages. They also understand that no single organization possesses all the data necessary to fully address these challenges or capture the full spectrum of the value. In the past, the challenge was the lack of data. Today, the urgent challenges of modern society are constrained by the lack of trust. Data islands maintained through regulation and policy that constrains multi-party protected data sharing is an issue. There are when data sharing does occur, it is often based on interpersonal trust relationships rather than a fabric of organizational trust. With Azure Always Protected, trust is accomplished through enabling trusted identity on trusted devices over trusted networks, enabling trusted applications which transmit and store trusted data. Data governance. Data governance is core to a data consortium. The trusted framework represents a data governance protocol, and platform managers have to document the types of data that will be accessed and define the intended use of the data prior to review, and they also maintain the trust charter and ensure ongoing alignment across stakeholders. These include data producer requirements and data consumer requirements, which are outlined on this slide. Next, a trusted data platform architecture has 5 components. One is a protected gateway. The second is a secure multi-party data lake. And next is a secure data policy enforcement document. and then open data repositories and gatekeeping functions that link to a common policy orchestration component, all within that trusted data framework that is documented. So open service and data catalogs are a registry of open data-based services interfaces that enables both policy-based access to historical or near real-time data sets, and it provides a gatekeeper function that integrates the Azure Data Marketplace and multiple open data platforms. The common policy orchestration facilitated by the trusted framework verifies the provenance and context of data residing within or published by the data consortiums. The next component is multi-party data lakes. The Trusted Data Consortium or ecosystem facilitates aggregation and analysis of multi-party data, and some of which is protected, while providing sufficient process guidance, automation, controls to ensure protected data is managed accordingly to common policy orchestration components, again, within that trusted data framework. The collaborative is made up of members that are legally bound to the trust framework and the rules through signed agreements. And these are electronic agreements, which are logged, again, on that distributed ledger. The third component that we'll talk about is these multi-party data lakes. So multi-party data lakes are public cloud-based implementation of a secure raw data storage with additional security mechanisms and controls to enable policy management and self-service administration. The security is co-located raw data from multiple data providers, making it immediately available while respecting conditions for access and obligations for use, again, through that trusted data framework. Finally, this is a slide that shows best practices that we have documented over the last 4 years in creating these trusted frameworks and collaborations, and you will get access to all these slides afterwards and can look through these. But they're primarily based on system security and then cryptographic protection of the data. So let's talk a little bit about differential privacy. This is a very interesting area around how do I protect privacy while using data. As the amount of data that an organization collects and uses for analysis increases, so does the concerns around privacy and security, which has been a running theme throughout our entire talk here. Analysis is required for data insight. And typically, the more data used to train models or AI models, the more accurate they are. But when personal information is used for these analysis and for these ML training models, it's especially important that the data remains private throughout the use. So how do we do this? Differential privacy for machine learning and analytics, it is a way of hiding the contribution of the individual's data. In traditional scenarios, we see raw data is stored in files and databases. When users analyze data, they typically use the raw data. This is a concern because it might infringe on an individual's privacy, and that's why we have high-tech and HIPAA and all of these algorithms that we use to try and remove that protected information. Differential privacy tries to deal with this problem a little differently by adding noise or randomness to the data so that users can't identify any individual data point. Differential privacy is a set of systems and practices that help keep the data of individuals safe and private, again, adding this noise. To ensure privacy in systems where multiple queries are allowed, a key component to differential privacy is around the rate limit. So to ensure privacy in systems where multiple queries are allowed, differential privacy has this rate limit, and it's known as a privacy budget. And this controls the number of queries, because we know if we run data over and over again, we can start seeing patterns. And so one of the ways, besides adding this noise to the data, is to have this privacy budget. In differentially private systems, data is shared through requests called queries. So I'm going to walk you through this use case or this workflow. So starting on the left, we have a user that submits a query, and that when the user submits a query for data, operation known as privacy mechanisms, or this privacy module, adds noise to the requested data. And so you can see there's data set checks, budgets, and then access credentials. So that's what we talked about in the previous slide. And then there's the mechanism that adds noise, and then we eventually have a report. And so privacy mechanisms return an approximation of the data instead of the raw data. This privacy preserving result appears in the report, sorry. And so reports consist of two parts. It's the actual data computed and a description of how the data was created. So this is a very high level, quick run through of differential privacy. At the end of my talk, I have several slides that give you the ability to do deep dives into these very interesting topics. And these are not theoretical. These are things that we are putting into use now. And I think very much
So I think we may have lost Tiana there temporarily, which is unfortunate because that was super interesting. But as Tiana was mentioning, as she said, these are not things that are theoretical right now. They are things that are actually being in market in most cases, or if they're not, then they're in public or private preview. As we go into the and will be brought into, in most cases, moving from public or private preview into full usage afterwards. Tiana was actually more or less at the end of her presentation. So I think what I'm going to suggest that we do is that we will continue with the rest of the agenda that we had here, and we can actually use the opportunity potentially to take some of the other questions that have emerged over the course of the morning as well, and use the next 5 minutes for that, and then we'll take our break as planned at quarter after the hour. So I just going to highlight a few of the questions that have come up during the course of today. Michelle, I'm going to put you on the spot. Are you able to come off mute? We'll see if Michelle is there and is able to come off mute. And if she is, we will.
Okay, I am back.
Oh, you're back? Okay.
I'm back. Okay. I'm sorry about that. Okay.
All right. I was actually going to use it to go through some of the other questions, Tiana. But if you want to wrap up for us, that would be even better.
I can do that. So let me share.
Okay, you can go ahead and reshare.
Sorry, let me get the.
It's kind of interesting as we're talking about all of this future technology, and still people struggle with, I don't know, internet connections out of their homes. It's kind of.
That is true. Okay, I looking for myself here. Oh, I think I connected to the other one. So instead of sharing my screen, what I can do is I can just talk through this. Well, let me see. Maybe I can do it now.
Or if you tell me where you are, Tiana, I can.
I think I have it.
Okay.
Here we go. Can you see?
I'll get it up there for you. Don't worry.
Okay. I can finish in 3 minutes.
Okay, you're good.
I apologize. Okay, so homomorphic encryption, as I was saying, I'm not sure when I dropped out. This is a core functionality that can be, or a core capability that can be leveraged in Azure Data Share, in Azure Always Protected, in any of our analytics and data sharing and storage solutions. So homomorphic encryption is companies, we created something that was deployed in 2015 alongside Harvard. This is an open source homomorphic encryption algorithm. We call it SEALS. It's Simple Encrypted Arithmetic Library. And companies often send and receive, store their cloud data in encrypted form. But to take advantage of cloud computing services, companies must provide either unencrypted data or the keys to decrypt it, which puts their data at increased risk. Homomorphic encryption allows computation directly on encrypted data. Very important. So being able to keep your data encrypted, but still be doing analytics on it without having to move it to a different storage container is huge. It makes it easier to leverage the potential of cloud for privacy critical data and security. So the use cases for homomorphic encryption is lightweight computations like addition, multiplication on privacy critical data and parts of programs. Also, you can do outsourced cloud computing where a single owner owns all the data and has full access to the decryption keys. So this was created in 2015. It's available on GitHub. It was in collaboration with Harvard. It is actively developed and maintained. Computations on encrypted data happen in milliseconds. It is widely adopted by research teams worldwide, written in C++. It includes full .NET wrappers. There's no external dependencies. It includes extensive examples on GitHub, and it's post-quantum secure. So I want to say thank you to everybody for participating in this webinar and workshop today. My information is here on the slide. You can reach out to me anytime. I'm more than happy to talk to you. And I'll quickly go through, here's our data, Azure Data Share resources. My slide will go forward. Open differential privacy, Microsoft Seal, which is our homomorphic encryption. And then we have our responsible ML resources, a whole list of all kinds of work that we've done around all of this work.